and I want to welcome you to my YouTube channel where you will find Atari, Commodore 64 tutorials available here for you. I have a focus on BASIC and assembly language mostly. And what I've noticed going on recently here, since I had a focus more strongly on the Commodore 64 probably for the last few months or so, and eventually I put up an Atari video here, which was just a basic Atari basic graphics video, very simple, just basically showing all the graphics modes and everything. And I was surprised by the number of responses I got on it, and I was surprised at how fast this one is growing. I was like, it's very basic information for me. I didn't feel like I gave you anything, but apparently I guess it was enough. It seems like what was really working from what I'm seeing here is for doing like a step-by-step kind of process where people can watch me step-by-step. So if that's something you guys prefer, let me know. I'm going to actually do that right now with a demonstrated program I have. And this is kind of on a side note, but I have a little bit more time now because I just lost my job again. Well, I don't want to go into a whole lot of detail about that, but I was in customer service, and I'm still trying to figure out whether I'm supposed to be in customer service or am I supposed to go back into software. I really don't know right now. It's a very confusing time in my life. But I do have a kind of a backup plan here, and I was going to kind of ask you guys if you were interested in this. So some of you like to do Ataris, maybe you have your own Atari computers. I wanted to show you something here before I go into the video example here. Some discs I want to try to put up on eBay. I have nothing but tons of these things. These are Atari diskette DOS discs. Last time I put up there, I got a pretty good response. People were happy for them, so I have probably, I think I have more than this. I have probably about maybe 15 or so right here. I bought them on a quantity deal I got several years ago, and I just kept them ever since. And I thought I was going to go become a DOS seller or something. I don't like a DOS disc seller, but just let me know if you guys think about that, because I'm going to try to get my eBay store going again. The only problem with that right now is there's an issue with my PayPal account. I'm hoping to resolve that soon. But anyways, I just thought I would throw that in there. So let me know if you're interested in some DOS disc. And I also have some Commodore software I can put up there too, some duplicate games and stuff like that. So let me know. But let's get back started here. So I've got a program I want to show you. I'm going to be using this book. I'll put the PDF later. You can get it. It's Atari Graphics. Kind of move it back there a little bit so you can kind of see Compute's first book of Atari Graphics. One of my first and favorite books I ever bought with the Atari computer. Well, it may not have been the first book, but I know it was the first one I bought on learning graphics, and it's been nothing but a pleasure. It's very well written. It's kind of like the dummies book of the days, if you would. So here's the program we're going to be using right now. I forgot to show you the name of it here. It's actually what it will teach you. It's kind of the next step I was showing you with the other video, which is using color and locate instructions to program Pong type games. Since this one is primarily focused on the joystick, I'm going to type it in like this, but I'm also going to utilize it for the keyboard and show you guys how to do that as well here. So let me just kind of go through it line by line here, and I'll show you. And here we got this crazy speed on this computer again. I've not been able to fix that yet, so it's really strange. But this one should really be hopefully beneficial, because you're going to learn about how to detect stuff, and you're going to learn how to detect collisions using screen comparison, I think they call it. If I can recall back in the days. This was a pretty cool program when I first typed it in, so it's not too long. Give credit to the guy that wrote it here, Michael A. Greenspan. I don't think he's related to the guy in charge of, what was his name? The Alex Greenspan or whatever his name was. This was a software developer, so back in the days. Well, actually, this does need to be a remark. So I'll go through and I'll explain this line by line. If you've been following along already, you'll probably know Graphics Mode 3 is right here, where you can basically, let me show you. You can plot points on a screen, and you can draw to those points. Draw will take it from here to wherever you want to draw it to. So if I want to draw to this corner down here as an example, I know it would be 39 in length, and it would be 19 down. So that would draw me straight down. Now if I wanted to plot a point in this corner and say draw an X up to here, I would plot it at 0 because I'm still at 0 line here, and I would plot this down at the bottom, which is at 19. See it? And then I would draw to the upper corner, just to kind of teach you a quick thing here. To the upper corner here, remember this is 39 across, so you would put it 39, and this is down on line 0, so I would put 0. Hopefully that didn't confuse too many people, but that's basically what you do there. So wanted to show that to you. And this other part of the program here is basically just establishing a variable. I went over those with the Commodore before, but just so you understand, with the Atari or pretty much any computer, basic computer back in the days, you had two types of variables. You had the numeric variables, and you see it would put the value in it, and you also had the string variables. I'll need to dimension this one to show it to you. You just dimension it like that, and then you just set whatever you want inside of it. More likely, the string variables were used for characters, so you could print characters in here, but you can also print numbers inside of here. You just have to convert them. For example, if I wanted to change this back to, well, actually, let me put a number in there first. If I put a number, it won't work with the letter, obviously. If I put a number in there right now and I print strings, it has a 1, but you can't multiply that by any number because you can't multiply a string by a number. You'll just get an error message. So what you want to do is you want to convert it back using the val statement. Sorry if I'm talking too fast here. I wanted to get this program underway too. And you print it, and it would show you the number. Now you can actually calculate with that number. I'm just going to do a little quick math here. And it would show you the calculations. And your S string still remains intact here, but you converted it using a numeric variable. So let's go back to the program. So you understand that that's a number alone. Okay, so the next one here is another numeric variable. You can set variable, I can't remember the exact length, but there's a certain length you can set them on the Atari versus the Commodore 64 where there are only 2 characters in length. I mean, you can make them longer, but it's only going to look at the first 2 characters. I know the Atari doesn't really seem to have I think it's 128 characters. Somebody will probably correct me on that, but that's a guess. Okay, so I'll explain this line here in just a minute. See, integer random, oops, times 15 plus 1. Okay, so what you're looking at now, like I said, is another series of numeric variables. You got A, let me run it to show you actually. And I'll go back here so you can see the examples. So you have S, obviously, which is 51. You have A, B, X, Y, and C. Now what you want to know and understand is B is going to be a single variable. It's known as a static variable. Basically, it doesn't change or anything. And then you have another variable here, X, another static variable. It's not going to change unless you put a value into it. So this one starts at 0. So all these are just regular initialized variables to whatever you want to use them for, like a game score or a counter or whatever you prefer to use them for. Now this next one I wanted to focus on here, which, let me run that again. I don't know why it gave me a 0 on that. Let me see. Okay, there we go. So now you see Y is actually a 9 and C is an 8. Let me run this again to show you. Now watch, they'll change. This time it's 15 and 7 because what this is actually doing is it's printing or producing what's called a random variable. I showed this on the Commodore. I'll show it again on the Atari here. First, without the integer, if you type a number like this by itself, it's going to show the decimal equivalent after it. So basically it shows all this stuff right after it. Now if you put the integer in front of it, where's that? Delete. I hit the wrong one. Integer. And you want to make sure you back up. And then also you have to close this, and so we opened it with the integer. Now if you print Y, I'll erase this and show you. See what it does is it takes off the decimal. You have no more decimals after it. So that's a way to get rid of numbers if you're not doing like calculations with them or anything. Preferably you see that a lot on the older computers. So. Okay, C does the same thing. It's just another numeric variable. So they're basically producing a Y integer in between 19. It's actually between 1 and 19, and that's because of this plus 1. Whenever you add a number to it, it's always going to add to whatever that random number is. So as an example, if this picks between 0 and 19, and you put a 1 on it, it's only going to choose between 1 and I believe it's 20 if I'm not mistaken. It might be 19. Let's see, 19. It has to be 20 because if it were 19, it's going to add a 1 to it. So it would be 1 and 20. And this one is doing the same thing. It would pick a number without the plus on it. It would be between 0 to 15. With the plus, it's going to be 1 to 16. So hopefully I've done that correctly. All right. So let's go back to the program here and add the next lines in. Next one's just a remark statement. This is plot the paddle. I wanted to show this to other people who wanted to know, but since we're doing an emulator, it won't matter. But if you ever played the old Atari games, these are paddles, and that's basically, whenever you see the word paddle on the Atari, that's basically what it's telling you is these are the kind of things that you could use with it. In this example, they're using a joystick, so I don't know why they wrote plot the paddle, but wanted to show you that, so people would want to know. So next line is going to be a color. You have what's called a set color, which changes the luminance. And then you have the plot and another plot here. I'll go through the step-by-step since the way this program is set up and show you what's going on basically. That should give you a feel for it, hopefully. Okay, so the first one is producing color orange because one is the orange on the graphics 3 screen. The next one I can show you by doing it manually here. Remember, it's going to pick a number between the C. So whatever is in C right now is going to be defined, which is a 1. You won't see anything on this right now because it's not actually changing this background. I think it's changing like 708 or something like that. So I think 2 is the background. Yeah, 2 is the background. So whatever you change this to, if you change this to like 0, it'll go to a darker color. So basically it's just printing out these numbers right here. Right there, 2, 1, and 0. Don't ask me how it works exactly. I've seen people use set color a lot. I always prefer to use like poke and kind of figure out the calculation that way. Maybe it's divided by 2, I don't know. Let me see. Let me see, plus 1. Maybe it's times 2. Maybe it's times 16. There's 16 colors in a palette. That's what it is. Okay, so it's 16 colors in a palette. That's what's going on. So you just basically take that number, which was 1 here, and multiply it by 16. That's how it's getting the palette colors. I knew I'd remember if I tried hard enough. Okay, so the next thing here is just taking and plotting at A comma B. So earlier you saw A was defined here as 35 comma 10. So let me show you that without running the game. I'll kind of go into the mode here and show you. Actually, it's not going to stay on the screen. Let me just do color 1 and plot. There's A comma B. So we'll just say plot 35 comma 10. And it's basically right there is where it's going to start the first dot, if you would, on the screen. The next line here is going to plot from that same dot, and it's actually going to move it down 1. So let's do that here. I should have done that at the same time. Sorry, guys. Oh, graphics 3. I'm just showing this for real time so people can really see what's going on. Run the program will do the same thing, but just to see so you can kind of get an idea of what's going on when I run it. It's just basically change the color randomly. So it's changing it each time based on that set color. So okay. Okay, let's see here. The next one is another remark statement. Let it paddle up. I was checking to make sure my Camtasia was on. Sometimes I forget to turn it on, so if I don't turn it on, it's only going to show the camera, so you won't see the screen, because Camtasia Studio records the screen, just so you guys know. So that's why you see me looking down at it from time to time. Okay, so this next one I'll show you. I'll type this one in, and then I'll give you an example on it here. B plus 1 equals B minus 1. Try not to get a habit of putting those spaces in. Atari will still remove the spaces, but it's just a good idea to kind of get in the habit of how the Atari looks at information. So you won't see anything when I run it, because it's not doing it except for that color changing every time. Because we haven't gone back to this routine for anything going on yet. But it's actually a joystick routine, so let me set it up in this line and kind of give you an idea. I'll just set up a variable here. We'll call it st equals stick 0. So there we have st equals stick 0. And then what I'm going to do is I'm going to print st, and I'm going to go back to 100 so I can kind of show you the joystick, or if you would, the Xbox controller. But remember, I said I would also show you how to change it to the keyboard. I forget where my Xbox controller went to. Okay. Wasn't ready. I don't know if it dropped on the floor or where did I move it to. Oh, it's sitting right there on top. There it is. Okay, so the Xbox controller is this, for those who want to know. So what I'm going to do is I'm going to go ahead and program the keys in again here. You just basically go to the input and you put in, I'm on the wrong one, I'm looking for joystick. Keyboard, not keyboard. I've always done this on the Atari. I'm on the Commodore 64. You know, this is the first time actually doing it on this one. Disk drive, cassette, input. I'm almost thinking that this, actually, you know what, I might have to skip this step. If I'm not mistaken, I don't think you can actually program the Xbox joystick using Altera. I don't see any examples here. Like this would all just be system information, video, disk drive, hard disk, so on. I don't see controls. I see console switches. No, that's just the console keys, so it's not that I can see it anywhere here. Alright, so it looks like it's not there. It would be an input, I would think. Maybe it is here. Wait. Gamepad, joystick. Aha, there it is. Look at that, I was wrong. Okay, so now I've got the joystick program. Let's see if we can get this to respond. There it goes. Look at that. It works after all. So I'm moving the controller. As I'm moving it up, the location is going to be 14 in stick 0. If I'm moving it down, it's 13. If I'm moving it left, it's 11. And if I'm moving it right, it's 7. So once again, 14 up, 13 down, 11 left, and 7 right. And the middle is obviously going to be 15, which is known as idle. So I wanted to show that to you. And I have to reset this thing again. I forgot. I still haven't figured out how to jump out of the break yet, so I always have to do that when reset. So we'll take the lines out, and now you see what 14 is doing. If you look at it here, it says B equals B minus 1, which will show you it's basically moving the joystick up. And I'll show you a quick example you can do here before we finish the program. If I go to line 40, I can show you what that's actually doing. So if I'm moving the joystick up, no, actually I haven't replotted it. You're not going to see it, but it erased it because I was trying to move it up. So we'll continue on to the rest here. Replot the paddle. So basically this was saying color 4, so it was erasing the dot you saw on the screen. That's why it never put it back on there. But if I print the values out here, actually I won't be able to print them here. I'm in immediate mode. Again, it's not going to let me do that because I did a reset. So anyways, if I was able to stop it, you would be able to see what the values are. So we'll get back to that. Let's go to line 50 here. This one is going back to 30. That's the one I was trying to put in earlier. So okay. Oh wait, it went. Okay, so this is the one. Okay, this is the line I was looking for. I'm sorry, guys. Now if I run it this way, it's going to go back to 30 here if you're moving the joystick up. And it's going to plot color 1 into where that little dot is there, so you'll be able to see it this time. I just didn't go to the right line. Okay. And I got an error message here. There's a line 30. Oh, I see what I did. I don't know if you guys see that. I put stick I. There's no such thing as a stick I. It would basically be looking for an array called stick I, and it doesn't understand what you're trying to say. So we'll run it again. Now if I move it up, there it goes. You see how it's moving. It's basically animating it. Now we haven't programmed anything else for movement yet, so I just wanted to show you that. They have a lot of remark statements in this thing. Move the paddle down. I just now saw that the paddle they're referring to as that dot. I guess I just call nothing a paddle because it says move the paddle down there. So stick 0 equals 13. You can kind of see a repetitive pattern going on here, but that's basically what you're doing when you're moving something around. You have to erase it and then redraw it so that the system can see where it's going to be at again. This one will move it up and down, and I'll show it to you. I also need to explain this out of part 2. I'll get right back to that. I kind of skipped over that. I know I went kind of fast there. So what this did earlier, you saw how it plotted that A comma B and A comma B plus 1 to put them kind of on top of each other. And then B equals B minus 1 is just going to move that B upward down the screen there, so you can kind of see it moving up. So it's going to keep track of where its original position was for your vertical. And it says if B is less than 0, then keep it at 0, so it doesn't give you an error message and go off the screen. This one does the opposite. It moves it down. That's what 13 is, and that's why it says move the paddle down. And it's going to basically move it down and check to see if it's at position 19 and set it to 19. Basically not let it go past 19. So, oops, I forgot to do the go to again. So let's go back to 30 again. And I'll show you how it moves up and down now. Whoops. There you can kind of see it's moving up and down now. It's a paddle, so it's not going to be just a little dot. It's actually, you know, like a paddle in the old days. If you ever seen like the old Pong games, this is kind of emulating like the Pong games in a basic kind of way. So I thought it would be good to show you because I grew up with Pong. It was my first game system, I guess you would call it. Believe it or not, it wasn't mine. My brother actually got it, but I got to play it, so it was my first experience with the little dot on the screen, and nobody has ever before in their life seen anything on a television screen. All of a sudden, there's magically a digital dot on the screen. Everybody went crazy over it. I wish I would have had the technology in those days and understood what I knew now. You could have made a fortune if you think about it. But anyways, moving on. So 70 is, let me erase 100 here again. Well, I'll leave it in this time so we can go back to it. We need to. So stick 0 equals 13, then go to 30. I'm going to make a note in here so I don't forget. I have a bad habit of forgetting stuff, so I'm going to say convert to use with keyboard. Since that wasn't the core of this program, I wanted to make sure I remind myself so I know what to do with it. So this one is basically just kind of trapping the lines, and this ain't really doing anything else. It's just telling you if you're moving the dot up, you want to make sure you go back to 30. This one's kind of he asked me, it's kind of sloppy in how they did it here, but I don't know. It's just a beginner program for people. And that's the whole idea, is to try to get these as beginning as I can for people who have never experienced the Atari or want to learn about it. So it's only fair. I mean, I could go all advanced on you guys and you would never join in, and it would be no fun for me. Okay, so that location, here we go with all their messages again. It's like 1 to S, it says. Okay, so plot the ball and hold it at its, I spelled location wrong. Hold it at its location while the computer counts from 1 to S. So it's going to do a little counting here and kind of freeze the ball in position. So that's what the next line's doing down here. The remark is always what the next line is going to do below. Those who want to know. Now we got we're going to utilize those other variables, the X and the Y that were created earlier, which were the random. I knew one of them was a random. Let's see, X was a random. No, X was a 0, Y was the random. Okay. X was just a regular 0. So it's going to plot it up in the corner and kind of position it up and down the screen somewhere. Basically, it'll be on this side, on the left side. So, okay, so let's see. I'm seeing for D equals to S. I see why they put S in there now. Next, D. Trying to see if that line would do anything. Okay, well, let's go back to it and see what happens here. So you see what's going on now? I can move the joystick up and down with a controller, and you see the little dot on the screen. Now, if I stop it and run it again, keep in mind it was down here, you'll see that it changes where it's going to position it. So it's just basically moving it around in different positions based on that random coordinate. So we go back here into the program. I'll show you. So it says right here, color 2, which is the color orange you saw there, and it's going to plot at X, comma Y. So X is always going to be 0 because that's what we initialized it to earlier up here in line 20. And then Y is going to be this random variable here between 1 to 20 there. So it's basically going to position it on the screen correctly and move it around so it looks kind of, like a game. So let's move on to the next line. Oh, and I forgot this part. The for D equals 1 to S is counting from 1 to whatever S is. And I don't know if we initialized S. Let me have a look here. Seems like I can figure out how to stop it again. Okay, so S is... Looks like they haven't initialized S anywhere yet. I could actually print it and see. There's actually something here. 51. equals 1 to S. I missed something here. Let's see. Oh, I'm sorry. It was the first variable we did. Excuse me. 51. So that's always going to be 51. So it's just going to be counting from 1 to 51. I don't know why they did that, but again, it was a beginner program. So next thing we're going to be doing here is we're going to use what's called a locate statement. And this is going to figure out what that is contacting. So the x plus 1, remember, that's going to be that little dot over this screen here. And it's going to be looking to see the next character in front of it, because that's what means x plus 1, because it's going to add 1 to it. It's going to keep it at the y position, and it's going to detect a z collision to kind of figure out what it's colliding with. Now I'll show you it. Hopefully I can reset it and not lose it here. Let's see if it keeps the values in here. Right there. So you saw x was 0, and y was our random position at 10. And z is 0 right now because it hasn't contacted anything. So what I think they're going to do is they're going to move this ball across, and you're going to have to hit it with the paddle. Obviously, that was the whole idea of Pong. So, okay, so now let's go into the next line. It's another remark. I knew it. Move ball to the right. Come on. This weird typing. If it has not reached the end of the row. I'll move it to the right if it has not reached the end of the row. So it's going to basically detect where that ball's at. Right now, this is just a remark statement telling what the next line is going to do. So let me go ahead and type that in. And we're going to lose our line 100 here. Now I'll have to put that back in. Whoops. Greater or less than. This right here is checking the collision of Z. That color that is going to be trying to collide with something there. Less than or equal to 35? Or greater than 35, excuse me. X is greater than 35. My book is blowing all over the place with this fan. It's so hot in here. Okay, so then this, now we have a new variable being initialized here. Equals miss plus 1. Try to get used to where everything is here. Okay, so hit. Misses. Miss. Whoops. I'm getting too close to the end of the line. So if you get too close to the end of the line, this is kind of a hint for you guys. You can abbreviate these commands here. Plot is PL period. As long as you put the period after it, it'll work. This one kind of ran out of room, so I guess they kind of expect you to know that. That's what that bell means. Basically, you're hitting the end of that line there. So I got it arrowed in anyway here. Let's see. Just like at 100 again here. I like to kind of list it by itself. Z is greater or less than 1, then if x is greater than 35, then miss equals miss plus 1. That looks fine. Hits, hit, misses, miss. It's right there. I see it. Now I'm going to have to erase all this because I don't have enough room to type in anything else here. So, oops, I just erased the wrong part again. As you can see on the Atari computers, they always produce error messages when they're checking that line. I'll bring it back here. And put that 36 back in there. Hopefully I got enough room to fix all this. 36 comma B. Oops. Lowercase there. It was missing a colon here. See where this miss is right here? I think it was this. Let me see. The miss equals miss plus 1. I thought I saw a missing colon here. Okay, so this part, well, this looks like it has double quotes here. Let's see, double quotes hits. Let me just double check this real quick. Like I said, the old thing in the days when you had a mistake, you would actually go back over and verify that line. I'm not going to try to sit there and rationalize what it is. I'd rather just kind of verify it. It's faster to find it that way. Looks like that part is correct though. Miss color 4. Oh, I see it. If I paid attention, I would see it. I put b minus 0. You have to put equals 0. It doesn't understand what that is. There's no such thing for b minus 0 to 10. You have to set what the computer's looking for, specific instructions. Okay, so we got that line. Now I could run it right now. It's going to give me an error if I try to go back because I haven't finished this for loop. I think it will. Let me see if I can do it without running the for loop here. And maybe it will work. Maybe this one it moves it or something. Looks like it's not doing anything. I press fire button. I don't think it's moved the ball yet. Oh, we haven't moved the ball yet. So let me actually show you what and explain again in the program what's going on. Okay, so what this is doing is saying, remember that location earlier where we were checking where the ball's at, and we're checking right directly in front of the ball there. That's what the x plus 1 means. So if whatever's in front of that ball is not equal to 1, and remember the 1 was the color of our paddle, then it's going to say if x is greater than 35, that's because the ball is going to be moving over here in a minute. You'll see it traveling here. And it's keeping track of where that x is moving. See right here's the x that's basically moving it in a horizontal direction. So if x is greater than 35, so you count here from 0, 1, 2, 3 until you get to 35, which should be somewhere down here where the paddle is, then basically it's saying if you haven't contacted that paddle, that's what this means by less than and greater than. It's also known as not equal to. Then we're going to set a counter called miss, which is another way for saying you missed it, basically. Increment it by 1 to keep track of how many times we're missing the target. And then it's going to keep track of hits here. It's going to draw little hits on the screen and tell you how many times it's hit something. I don't think we've actually programmed this part yet. And then it's going to show the misses here. It would show in 1 if we missed it the first time, 2, 3, and so on. And then here it's going to say color 4. So it's turning off something here, and it's going to say for b equals 0 to 19. So it's setting a loop from 0 to 19. And what it's doing here, if you look, it says plot 35. 35 is telling how far over it's going to be. So 35, by the time we've x greater than 35, that means the ball's somewhere over here near the paddle. We want to erase it. That's basically all that's saying is erase it. And then 36, b is also going to be erased because it's at position in front of it. I do believe that's it. Okay, so let's go on to the next line here. It's a pretty short program. We're almost at the end here, and I'll be able to convert it for the keys for you guys. Next B. Oh, there's our S finally. We're doing something with our S, I mean. Once you run it, you'll be able to really see the whole thing in action. So this one's going to say if you haven't contacted, if you haven't hit anything, then we want to increment through the next incremented loop. When you see a for b equals 0 to 19, that's a loop, so it's counting from 0 to 19. Starts at 0, 1, 2, 3, and it keeps incrementing through here. So this is going to keep track of where that thing is moving at. Now b is moving it on the vertical. This is on the horizontal, so I'm trying to figure out if the ball is moving over this way, it's going to be at position 35. So I think that's just going to erase the paddle or something there. But in this case, it's going to do that, and then it's going to increment this S, which was, it's incrementing the timer. So what this is doing is every time you miss it, don't get the target, it's going to basically increment this loop. And I think it looks like it's going to slow it down. Because if it's incrementing and this starts at 51, then this is going to increment it by 10, so it's going to be 61. So I'm not exactly sure what they're doing with that yet. So let me run it. I got an error message here. So let's look at 20. Is there a 20? There's a 20. Trying to see why it gave me an error message. Go to 20. Next B. Okay, so what we can do, I'm going to teach you something new. Whenever you're getting an error message here, there's a way you can look them up. I have sort of an idea what this one is, but I'm not exactly sure. So what I want to do is you want to go to this book, or I'll find a PDF online. It's for the Atari. This one's just the XE system because I used to own the XE system, but it's your owner's manual. And you want to turn to the back in Appendix D. This will show you a list of all the error messages for your Atari computer, and I'll kind of zero in so you can see 13 there. I knew it had something to do with the for loop, but I wanted to show it to you. See where it says right there, 13. If I can get it to freeze here for a minute. It says no matching for statement. A next was encountered without a previous for or nested for next statements do not match properly. So that's saying that somewhere here we have another next statement that it's not finding. So that's why I'm wondering why they did the next B kind of thing here. I don't know if this program ever worked correctly. I thought it did. Maybe I missed a for statement here somewhere. I noticed the next line has a for statement in it too, so I think I just now saw what it is. So right now, if I print Z, Z is going to be 0 because it hasn't yet equaled anything, so it hasn't made contact with it. So what this program is actually doing is it's skipping 120 because it hasn't been able to figure out that Z is not equal to 1 yet. So it's not looking at this line because Z is not equal to 1. So it's never seeing the closing of the next B. I think that's a bad idea, but I've seen programs do that in the days. So what they usually do in the days, let me put in first this remark statement. This one's for the hit. They actually stick it in another line. And they stuck it in 130, which is the last line of the program. I kind of stayed away from this and kind of used Go subs and stuff after I got used to them back in the days. But like I said, it's a very basic program for people to learn from. You can type it in yourself. You can kind of play with it and kind of get moving on your Atari. That's the whole general idea of why I like to teach the very basic stuff. Here you can abbreviate color. You can just use COL period. Those abbreviations are pretty cool when you really get to know them. I think 4 is like F period if I recall. So here's what I would always do. When I'm typing in a million plot statements, I would do PL period. And then draw to is DR period. We don't have a draw to in this case, but you can use them that way. And then now we got go to 20. I have a feeling I got an error in this line, but we'll see. Oh, no errors. So now what this next line is going to do, it's going to say hit equals hit plus 1. So basically this is saying if you haven't contacted it, then it must, if you haven't missed it, then it's going to be a hit basically. So this, otherwise it would go to this line and do the next B. Otherwise it's going to continue down here and pick up the next B. I know it's kind of silly to have so many in here, but that's kind of how they did it here. And I just noticed I forgot my next B in here, so let me put that back in here. It's right after this 34. No, I have it right there. Okay, my bad. So it's right there. So it's going to print the hits and the misses. You'll kind of see it once the game's running here. It's going to keep track of the number of hits and misses, and it's going to calculate again. So when it's hit, it's going to subtract. Here's what it is. This is what I was trying to figure out. When it's hit, it's going to speed up the game because we were setting a loop starting at 51. This kind of slows down the program. And if you hit it, it's going to subtract it from 10 each time, so it's going to eventually speed up the loop. And eventually this loop will be gone, and you'll see the paddle going faster and faster across the screen. But if you don't, it kind of slows down the game. It's kind of weird how they did it here. But let's go ahead and get it going. Oh, I still got that error message in here. Okay, so it doesn't like that it's not seeing the other line. I'm almost wondering if I had to correct this or maybe I skipped a line here. Let's make sure I didn't skip a line. Just double checking things here. I have not tested this program. I just kind of ran it on itself. I notice I'm missing a remark. Not that it really matters, but for people who want to know, I'll just type in the next remark there. So I've got 90, 95. I do have 100. Let me, oh, 100's incorrect. No wonder. Maybe that's what's going on. 100 is not supposed to be greater than 35. It's actually supposed to be less than. And I'm going to have to abbreviate this. So what you can do to make some room here, because I'm going to have to bring back some of this to add some more stuff in here, is hold the caps lock key, press delete, so you can kind of bring it back there. Oops. You can do the same thing here. Kind of squish them together so we have room here. Now I'm going to be able to insert this like that and say less than or equal and erase this to 35. That's how it looks in the book. So 110, I don't have 110 in there. I just noticed I skipped that one. So I have greater. So 100 shows less than or equal to 35. So I know that one's correct now. And we need 110. We don't have 110 in here. So let me add 110 and it'll make it probably make a little more sense here. So it's another if z is greater or less than 1. then if, this one I was confusing with, x is greater than 35, then miss equals miss plus 1. Let me just type it in here again. My book is blowing all over the place here. Okay, hits. I think this is a duplicate of the other line, but let me just... There could have been ways that this program could have been reduced, and basically that would be by doing a go sub to this line, but like I said, it's very basic, so I want to teach people the basics. Let's see. Color for, there's a for statement in here. You can kind of squish them together like this too. That's the fastest way to do it when you're typing in a long Atari program and you think the lines are going off the screen. It's just squish them all together like that too. Now there's other things you could do, but I probably won't go into a live example here. I think you could just change the, maybe I showed this in another video. Let me show the right location here. I think it's 84, maybe it's 85. Trying to figure out how to change the screen coordinate. I think it's 85. Well, anyways, let's get back to this anyway. I was going to try to move the cursor from here to here. I'd have to look up which location. I don't remember which one it is. So let's want to double check line 120 because it looks pretty similar to 110. Looks like 120 is okay. So I have two 100s in here. I see why I missed it. There was also a remark here. I forgot the miss part. It's a miss. Sorry, guys. So that was the part that threw me off. That's why it's important sometimes to put the remarks in so you can kind of follow along what's going on here. So z is greater or less than 1. Then this one is describing... So let's go back to 100 since I explained that differently earlier and I typed it in differently. So it's saying if you haven't contacted the ball yet, if it hasn't hit anything, and your X position, basically wherever that ball's moving, is not yet equal to the paddle, then it's going to increment a miss. Basically it's saying by the time you've hit that paddle, if you haven't, then you've missed it. Otherwise you've hit it, basically. And that's this one up here in 100. Let's see, X is less than 0, hits, misses. Oh no, I'm sorry, that's the one down here. My bad. This is the last one, I think it was. Did I just erase it? I just erased 130. It was this one right here, determines the hit. So I gotta type it in again. For some reason I must have wrote over it somehow here. Abbreviate color COL, period. I think go-to is GO. Let me see if that was it. Yeah, go-to is just GO period per abbreviation. So now we've got this all working. Looks like it's caught in a loop here, so we'll see if it's going to run it now. Something is wrong here. So it's not moving the ball. See what it's doing? This is why it's important to really, you know, well, basically I'll say in this case it's good that we did this so we can kind of learn from it. So basically right now what this program is doing is it's not able to move this paddle, probably because I haven't changed the variable for it somewhere here because I typed in. I'm going to double check those other lines here. It's a good way to really learn from the program too. So I'm just going to kind of verify them here. Oh, so this line is totally different. Oh, okay, so that's what's going on. 100 is different than it looks over here. So I was making it like the other one, but it really says if z is greater or less than 1, then if x is less than or equal to 35, then color for, this was about to erase it, and here's the movement. So color for plot x comma y, there's the movement. X equals x plus 1. That's going to move that ball forward now. So to go back over this again, what this one here is saying is if you haven't yet contacted anything, so z has not hit anything, and x is not yet equal to where the paddle is, so it's less than 35, because it's keeping track of where it's moving at, then you want to erase that ball as it's moving across the screen at X, Y, because that's where we drew that original dot. And then go back to the line and kind of repeat the program. So it starts running instantly here. There it goes. Now it's going to be looking for it. Now if I miss it, or if I don't hit the ball, watch, it'll keep track of the misses. And also going to keep track of how many times you hit it. So if you it's a pretty simple game. If you put it in front here, it'll hit it. Oh, so now we got a hit. See how it went to 2? We'll get another hit here. You'll notice it'll get a little faster now, because remember that delay loop is decreasing now by 10 each time. So now it's getting a little bit faster, harder to position it. It's also kind of interesting. It changes the colors. This would be really cool writing this in the assembly language, though, because you could make it super fast, you know. There it goes. Now it's like at top speed. It's going to be a little bit harder to play it now. Oh, I actually missed it. That's the whole general idea of the game. This is a simple little Pong game. What we could do is we could even add, but first before I do that, I didn't want to make this video super long. I wanted to add the keyboard controls in for those who don't have the Xbox controller. So we're going to convert it over to the keyboard. It's going to take a little bit of work because we're going to have to remove all these stick positions and replace them with keyboard component. So I'll show you how to do that here. So we're going to add our own little flavor to it. So I think I'm going to stick it somewhere at line 36 would probably be good. I'm just going to call it keyboard, or KY for keyboard, and you set it equal to peak 764. That will read the keyboard. And let me show you how that works again for people who want to see the program in action here. So I'm going to set up a line here and test it. Peak 764. You can also do something like this, go to 1. It'll still go back to the same line. Now it's whenever I press keys, it's going to keep track of what those keys are that I'm pressing. So I'm trying to think of what would be the best keys for people to have. We could probably use like the mirror, what do you call the keypads? I could probably use the 4 and the 6, so that would be 24 and 27. Let's do those instead. 24 and 27. Oh, I'm sorry, we need to move it up and down. I'm like doing Roman. So we would be 8. So 53 and 30. Up is 53 and 30 is down. So 53, 30. Let me just make a note here of myself. 53, 30. And get rid of line 1. Now we're going to check this keyboard because KY is checking whatever the value is in K for the keyboard. And we're going to, we could even make this additional, we could make it work for both. Let's just do it that way to make it more interesting. We have the joystick here moving out, so we're going to basically control this to the keyboard. This is going to require a little bit more programming. I'd have to duplicate this line. For now, I'll duplicate this for beginners, but later you could set a go sub and make it go to the same line for the stick and the keyboard. If I had time, I'd show you how to do both. I'm just going to go ahead and duplicate that line for the keyboard for consistency's sake. So we said 54 was up. So we're basically going to be repeating what this whole line is showing so we can activate the keyboard. B equals B minus 1. Oh, actually, I need to do this and I'll explain why here in a minute. B minus 1. Okay, so what this is saying is if you press the up arrow key on the keyboard, where did I put it? Line 6? 53 is up. If you pressed up here, actually 53 is up. I put 40, 53. Excuse me. I realize I got to squish this in again here. Oops. I hit the wrong one. It's caps lock when you want to delete. I was trying to hit that shift key again. So delete. Because we need to make room for this down here, because this is already off the screen down here. We're not going to be able to type in the rest of the line otherwise. So delete. Delete. Now we got it all in the same line there. We can change it to 53. Okay, so let's go back and look at 40 again. So this is saying is if you press the up arrow key for 53, then we're going to do the same thing as this line basically. But the 764, 255 will clear the keyboard buffer. If you don't clear the keyboard buffer, it would leave the up key stuck and you wouldn't be able to use the other keys. So it's always important to clear the keyboard buffer, which poke 764, 255. Okay, so we'll add the next line in here for 30. But we need to do the same for all of these, otherwise it's not going to match what the program is showing. So I'm going to take a shortcut here since I did this one for this one. So this 40 was taken for, something that I just duplicated. I think I just duplicated one down here. I should have done it in that order. So I'm going to move 40 and stick that at 50. Shucks, what did I do here? Plot A comma B. I think I changed this line. B is less than 0. I think either that or I just erased it. I think I just erased it. Yeah, I did. That was actually that line, and I just erased the joystick. Well, we don't need the joystick. We're just going to go erase the joystick then. But I was going to originally make 2 lines for each one. We'll just take out the joystick, I guess. Okay, so line 50 will be our next one. So instead of saying if stick 0 equals 14, which 14, shucks, I knew I was going to forget what was up and what was down. Let me go back and look at the program. I can kind of read it and see it. So move the paddle down, move the paddle up. So move the paddle down. So down is 13 and 14 is up. So we need to change line 50. And I need to make that match what 40 is showing with the key equals 53. So we're just going to take out this. Let's say k equals 53. You can just take all this. It'll remove the spaces and format it properly. Okay, so we got the 53. Make sure I got all of them here. And now we're going to use the 30 and replace it for line 60 and 70, it looks like. I forgot to do something else here too. I don't know if you guys caught that right away, but what I told you earlier about putting the poke 764, anytime you're moving that key position and you press that key position, you have to use that poke 764, otherwise it's going to not respond correctly. So I'm going to stick it in here again. It's a long version. Thanks for bearing with me on this. It's not my favorite way of doing it, but hopefully they'll get the job done. Same thing for this one. It said before they go to 30 here, we're going to stick it down right in here. If I've done this correctly, it should work. Oh, should go to the right poke. Don't ever want to put in the wrong poke if you hit the wrong location. Sometimes you can lock up your computer. So let me just double check here. Make sure there's another stick position at line 70, so I need to add that one in for 30. Oh, I did. I just forgot to change the key. That's what I forgot to do. Okay, so change this to key equals 30. Now I'll run it and I'll come back and explain it to you so you can understand. This time, if I've done it correctly, it should work with... Yes, it's working. Keys are a little bit slower than the joystick, but I'm moving the keys now and it's responding to the movement of the keys. I'll explain it one more time just so that if you guys missed that in any way. This game is actually pretty easy to play once you get used to it. Except when it gets way up there. That's where it can get tricky. And I remember when I first typed in this program, I eventually started and created my own little game off of it. I unfortunately don't have it anymore to show it to you, but it was basically similar to this one, but I think I called it fastball or whatever. I had the ball moving really fast and hitting various targets or something like that. So let me go back and explain that line to you, and we're just about done with this one. For those who were keeping up, you would already know, but the key equals 53 saying if we have pressed the number 8 key, which is corresponding to the up key on the numerical keypad, that means we want to replace what the stick position, I think it was 13, was shown originally there. And then if we pressed it again up, press the number 8 key, it's going to go to 30 to go back to that line. This one is if you pressed it down. 30 is for the down, which is the number 2 on the numeric keypad. And then this would just replace those stick positions again for the down key for the number 2. So that's basically how you get the keyboard to work. You can use that little shortcut I showed you earlier. Let me show it to those for those who may have missed it. You just take print peak 764. You can do this with any memory location, but I'm just showing you with this one. And you go to that line to do like a test on it to kind of see which keys you're pressing. Like this is the space bar, this is the enter key, and then that's how you see what's going on with your computer basically. So, okay. I guess that's about it. I'm going to show you for this program. I wanted to add some my own stuff to it, but I didn't want to make this video super long and too confusing for people who are just getting started, you know, with Atari Basic Programming. So I hope you guys really enjoyed this video as much as I enjoyed bringing it to you. And let me know how you like these kind of examples of just type in programs and, you know, type as you go kind of things. I could probably utilize some more of these. Now for the Commodore people who are still keeping up and watching, I'll get that other video going really soon as I can. I did mention this, I do believe, in comments, or maybe to a few people, but I'm working on trying to get some scrolling done, fine scrolling for that Commodore program. I'd like to be able to implement fine scrolling into it if it is possible. If not, maybe I'll just do some updates to show you what's going on. But it looks like the Atari videos are happening, guys, and I can hardly wait to get the Commodore 64 game done. No pun intended to you guys, but it looks like the Atari thing is really moving along here. And unfortunately, Atari was my favorite computer of all of them. Even though Commodore 64 kind of stomped it in graphics and sound and stuff like that. I don't know, Atari for me was easier for me to learn graphics programming and to get my own game designs going as fast as I wanted to. So, hope you guys enjoyed this, and thanks. Definitely subscribe if you're interested, and I'll keep rolling them out as you keep bringing the requests in. Have a good one.